Today we're going to be talking about dilations. We're going to look at a couple definitions first. The first one is dilate, and this means to enlarge or reduce. In size. Next, we're going to look at scale factor. We used scale factor before, and now we're going to use it again when we're doing dilations. But this determines how large or small an object will become. A scale factor greater than 1 means an object will increase. So this is talking about whole numbers. And a scale factor less than 1 means an object will decrease. So a fraction. A dilated image will always be similar to its original image. So I want you to think back to when we did similar figures, where you had a larger triangle and a smaller triangle, and you wanted to see if they were proportional. This is what we're going to be doing with dilations. So let's look at these coordinates below. So example 1, you have A is 5, 3, and B is 2, 5. Now we want to look at their primes and figure out what was the scale factor here. So to get from 5 to 10, you had to multiply by 2, and let's make sure that this is true for everything else. So 3 times 2 is 6, 2 times 2 is 4, and 5 times 2 is 10. So our scale factor is 2. We had to multiply our original by 2. Now let's try the next one. So to get from -2 to -1, we needed to multiply it or divide by a half or divide by 2. Let's look. 4 times a half is 2. 2 times a half is 1. And 8 times a half is 4. So our scale factor was 1/2. You might have saw it as dividing by 2, but you're not going to want to write it that way. You want to write it as a fraction, so that's why we're going to write 1/2. Now we're going to So the first thing we want to do is plot our points. We're going to make each point 2. So 2, 4, 6, 8, 10, 12. 2, 4, 6, 8, 10, 12. So let's plot our original points. We have 1, 1, which is going to be right here. And then 1, 4, and 4, 1. So here is our original triangle. Now we want to make our prime points. So our prime, we're going to multiply it by a scale factor of 3. So 1 times 3 is 3. 1 times 3 is 3. For S prime, 1 times 3 is 3. 4 times 3 is 12. And T prime, 4 times 3 is 12. 1 times 3 is 3. And now we want to plot these points. So we want to go 3, 3, which is going to be here, 3, 12, and then 12, 3. And if you should agree that your prime is about 3 times larger than your original. All right, let's try our next one. Let's go ahead and plot our points, and again, we're going to use it in sets of 2. So 2, 4, 6, 8, 10, 12. That way. So we want to do -3. So 1, 2, 3, 1, 2, 3. And then 0, -9, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then -9, -3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, and then negative 12, negative 9. So hopefully you graphed this trapezoid. And now we want to apply it by a scale factor of 3. So we want to divide everything by 3 or times it by 1/3. So negative 3 times 1/3 is negative 1, negative 1. N prime is going to be 0, negative 3. Q prime is going to be negative 3, negative 1. And D prime, negative 4, negative 3. Now we want to go in and plot these points and see that we should get a smaller image. So negative 1, 1, 0, negative 3, negative 3, negative 1, and negative 4, negative 3. So there is our smaller image. All right, let's figure out what happens if we are going to write a scale factor by negative. Let's go ahead and plot our points. And we're going to do them in sets of 2 again. So 2, 4, 6, 8, 10, 12. So and the same. 2, 4, 6, 8, 10, 12. So we want negative 2, positive 1, which is going to go right here. Negative 5, positive 1. And negative 2, 2, 4, 6. So here's our triangle. Now let's see what happens when we multiply. We're going to use a scale factor of negative 2. And then we'll describe what happened to our figure. So let's multiply everything by negative 2. So negative 2 times negative 2 is 4. Negative 2 times 1 is negative 2. A is negative 2 times negative 5, which is 10. And then negative 2. And B is going to be 4, negative 12. So let's go ahead and plot our points. So we have 4, negative 2. We have 10, negative 2. And then we have 4, 12. So if we go by negative, you can see it is larger, but it also reflects. This is a reflection. So go ahead and bring these notes with you tomorrow. We're going to do a little practice, and then we are going to start a project tomorrow on dilations. So make sure you bring your notes so that you can use them.